Okay, welcome back, ladies and gentlemen. Today, we are talking about three major topics, one of which is piecewise functions. Let me just give you a brief picture of what a piecewise function would be like. Imagine for a moment that there's a function that was made up of two functions. One was the parabola that goes this way, but on the left side, it was actually an absolute value that goes like that. Do you get how that's still a function because it would pass the vertical line test? All right. But it's half absolute value and it's half parabola. Well, how would you define that? You'd go like this. You'd say, well, it's half absolute value, so it's got to be y equals absolute value x. And it's half parabola, so it's got to be y equals x squared. But then you just have to say when it's each part. And when is like the domain. How do I stop this from being absolute value? I'm graphing absolute value, absolute value, absolute value, and I want it to stop. Just stop doing that. Well, then, I got to say that it works for what values of x. So you say as long as x is less than 0, I want you to be the absolute value function. But as soon as x is greater than or equal to 0, then I want you to be x squared. Where are the major disputes between countries? It's always on the border. We have a border dispute now. There's not really a dispute, at least in the border that has been talked about in politics a lot lately. It's a pretty clear border. We all know where the border is. But there are some countries that actually disagree with where the border is. And then they say, I own it. And the other country says, no, 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 we own that. And so those are tougher border disputes because it's hard to argue who owns it. Like the way I understand it, Kashmir is an area that is claimed by Pakistan and India. They both say we own that. And so that can cause wars even over that kind of stuff. And so why am I talking about this? Because there's a border between these two functions. That spot right there. Do you get that only one of them can own it? You can't have both of them own that spot. So, can you tell by the way I did the domain which one I am saying owns that spot? 0 is the spot, and I said greater than or equal to 0 on the parabola, so it gets to have a filled-in dot. The other one doesn't. So usually, I'm going to exaggerate this, but usually we have a big empty circle around it in that color, so you can see, oh, it gets up to that, but doesn't own it. It doesn't get to, like, they can't both own it. It's one or the other. All right. So that's an example of a piecewise function. Now, one other thing, you get how that said y equals and y equals? They usually just simplify that down to 1 y equals, and then they put a bracket like this. There. That's a piecewise function. All right. And that's all there is to it. And that's an R3 level question, which is supposed to be a hard question. So it's actually kind of on the easy side of an R3, but there's plenty of opportunities to screw up. And usually it's on the borders. Usually people mess up on the borders. All right, let's see if you really caught that. I'm going to put up another graph. And I'm going to say, I'd like you to graph, instead of the other way around where I gave you the graph and then I wrote the equations, I'd like you to graph this. This is going to be x squared, where x, I'm going to use an interval from -infinity up until 0. Notice I use parentheses at the end. That means, does it own 0? Does the x squared function own the 0? Nope. Then it's going to be x. Now that can be confusing, but it's just y equals x from 0 to 3. And then it's going to be 2x plus 4. Not that's adding too much. I'm going to subtract a little bit, actually. 2x minus 4 from 3 to infinity. If you were going to graph that, do you get that there is 3 parts to this function? And I think the smartest way is to say there's this zone here where it's going to be one graph. And then what's the other kind of dividing line at? 3. At 3, there's another dividing line here. And then you can think about it like this. Okay, so there's got to be like a part of this graph, part of that graph, and then part of this graph here. And where's the trouble always at? The borders. It's got to be careful if it's like solid here and empty here, or is it like solid here and empty there? That's kind of what your answer is going to look like. Now, I know you have the capability with an iPad to pull in some graph paper. I strongly recommend you actually use some graph paper here to do one really nicely, okay? So do an import, and there's 2 options. You can hit the wrench, or you could put a sticky and put a sticky note in. If you put a sticky note in that has graph paper on the sticky note, that works too. You pick, but get some graph paper on your Notability doc. Then, again, I'm not saying that what I just did is the answer. I'm saying it kind of looks like that. And be really careful at the borders. Now, these dotted lines I have running, that's usually the sign of an asymptote. You do not have to have those dotted lines in there. And technically, they're not there. I'm just trying to show you that my Franken function is divided up into 3 parts. All right. So go ahead and give this one a try. Try to show me what that graph looks like. I'll pause for a minute while you give it a shot. Hint, what happens if you're stuck? The last one's usually the one that gets people. And you don't know what the graph should look like. Because you're used to graphing it all the way over here and saying it starts at -4 and has a slope of 2. How are you supposed to do that when you're only graphing this part of it over here? What's your best friend in graphing? XY chart. If you want a bunch of points that are on this graph, because I'm telling you, this is the one that's going to mess most people up. If you want a bunch of points that are on that, then just make an XY chart, pick some points, and find out, oh, this dot is on it, and this dot is on it, and that dot is on it. Okay? All right, you need a partner for this one. These 2 rows slide next to each other, except in this case, it's going to be you 2 guys working together. Would you turn sideways or something so that you can work together? These 2 rows slide over 6 inches apart, please. In these 2 rows, 6 inches apart. You get to join whatever group you want to. All right, I'm going to pause for a minute. And, okay, we're back. So, to graph this, first of all, I know it's a parabola, and I kind of know what they look like, and so I'm just going to go like this, and I also know that it doesn't own 0. So I'm going to put a little empty spot there. So the blue part is your parabola. Now, I was a little, vague on exactly where those dots are. On the test, this is one of the reasons that it's an R3 on the test, is you have to actually have some dots in there. Like, for instance, what are some things that are on y equals x squared? Well, I like these to figure that out. And if x is 2, y would be 4, for example. But that would be over here, and I'm not over there. I'm only where x is between -infinity and 0, so I need negative numbers. Like -2 gives me 4. So if I'm going to be a little more specific, like you would have to be, I'm going to go to -2, comma 4, put a dot right there, and that's a much more steep parabola than what I was implying. Okay, any questions about that part? All right. Next, would you agree that y equals x is the next equation? In case you get all lost in this, it's just y equals x. Do you guys remember what y equals x looks like? It's like this. But a kid who just draws it like that is not being careful with the domain, because we can't go into that negative area. We can only start here, and it has such famous points as 1, 1, 2, 2, 3, 3, 4, 4, etc. Okay? Then when does it stop working? It stops working when it hits 3. Now, I like to think of it as a dotted line running through there, because that helps me see that, okay, that's the dividing line, and now there's a new function that's going to start over here somewhere. All right, and who owns this border? Well, this has this guy owns the 0, but doesn't own the 3. So it owns the 0, so I'm putting in a filled in blue dot here, but doesn't own the 3. empty spot there. Okay, and then last but not least, like I told you, XY charts are handy for this. Y equals 2x minus 4. I'm going to make an XY chart. And what numbers are going to stick in? I know I have to be bigger than 3. Or actually, 3 is the first one, so I should start with 3. If I stick in a 3 in this function, it's 3 times 2 is 6, minus 4 is 2, 3 comma 2, over 3 up 2. Now, this bothers people sometimes. Like, there's a jump between those two things. That's okay. It's legal. It's called a jump discontinuity. The function is not continuous because it has to drop down here to continue on and be a straight line that has a slope of 2. So if you just are smart enough to go, okay, slope of 2, rise 2, run 1, rise 2, run 1, you can do it that way. Or you can find a few more points. Like if I put in a 4, that gives me an 8 minus 4 is 4, 4 comma 4, over 4, up 4. There's a dot here, and it goes on from there. There you go. Now, do you get, a lot of kids will have messed up that part right there. Because they will think that it has to connect. It does not have to connect. Or they will put a solid dot on both of them, and then it would fail the vertical line test. So that also would be a problem. So these are, like, not that hard. These are easy R3s, but you got to be careful. All right, so what's my final answer look like? And this goes forever because it goes to infinity, and that goes forever, so I have arrows on the end of it. And there we go. Now, this is a little strange. What's the domain of this piecewise function as a whole? Domain, yes. Yep, negative infinity to positive infinity. Because it goes forever in both directions and never has a gap. You might think this is a gap, but that's not a gap on the x. It uses the x of 3, and there's no gap. How about on the y? Yes? From 0 to infinity. And how about this? Is the 0 used, or is it touched at 0? So should I put a bracket? Yes, bracket. There you go. Okay. That's piecewise functions. I only did one for you, but I think you get the idea. I mean, I guess I did do one before this one, so I kind of give you the quick overview. You did one. That's how fast Spanish Pre-Calc has to go. Like, you have to be able to get it from that. If you need more help, I am here tomorrow morning. Thursday morning is one of the days. It's all written on the board up there. Mondays, Wednesdays during Mass, and Thursdays. So, all right. So what else do I have to teach you? Something called implied domain. I'm going to go over to the regular smartboard for this. You have these notes. If you could have them up on your iPad, that would be great. And I'm also going to just introduce that there is going to be a lab about this. I know we haven't graded the other lab yet, the Venn diagram one. That's going to be the easiest lab ever. Ask some friends and, you know, fill in a Venn diagram. That will be graded eventually, but we're still kind of in a holiday zone here, so we're going to grade that later. This lab won't be doing for at least a week, and that's typically how these work. Is I'll tell you about the lab. My wife was one of those eager beaver type high school students, and even college students. And if they would assign a paper like that's going to be due in 2 weeks in college, she would just like do it on day 2 and be done with it and annoy all of her friends. She wouldn't like rub it in their face or anything, but they'd be like, "So you're working on your paper?" "No, I'm done with it already." It's like, oh, it makes everybody else feel bad. So if you're that kid, well, here's the lab, and if you go look in the labs folder, it's there, and you can just do it. Because frankly, it's about piecewise functions. What we just did, that's all you need to know to do this lab. So does this kind of look like 3 chunks of a function? It's this function printed here. It looks like a parabola from there to there. And do you guys recognize that one? What function is that one? Square root function. So how do you get the square root function to only work from there to there? Well, again, you got to set its domain. All right, I will give you a good hint on this. On this lab, Desmos works really good. It's an online calculator, and we do have the app on our iPads. You can get it from the little Minnetonka store or whatever. So the Desmos app is really nice, and it works really well for this lab. And all you're really producing is you're making a little roller coaster where it has to follow certain rules. Like on a roller coaster, they don't just tell people, "Hey, do whatever you want." You know, you can't have people enter the roller coaster at 700 feet off the ground. You know, like that's not realistic in the real world. They'll have some rules, like you have to have the people get on the roller coaster at about 12 feet high off the ground, and then the roller coaster can't go any higher than this. And anyway, you have rules about the little roller coaster that you're making. Okay, so you get some creativity then. We try not to be like, here's the exact steps. First do this, then do this, then do that. One tip I will give you is these are required to be certain things. The x-axis here, this is not required to be certain things, but it would be smart for you to pick them. Because do you get your domain always goes from like here to here? So you should pick how many feet this is, and it's your choice. And again, you can pick how many feet that is, and it's your choice. But pick something, because these dividing lines where you have your three different functions are really important. So you get some choice in this, but figure out what you want your x-axis to be. All right, there. I've introduced you to the Mad Mouse Lab. It's got your classic 20 points, and there's 2 points for the sketch, etc. That's on the 2 points for the conclusion and stuff. That's in the lab format for all labs. All right. Now, there's domain and there's range. Domains are the inputs. They're also known as the x's. The y's, also known as f of x's, are the range. Inputs, outputs. The only other thing I could add to this slide is that the x things are the independent variables and the y things are the dependent variables. Okay. And if we asked you to find g of 5, it would be kind of nice back in higher algebra. We would have just said g of x is 2x minus 7. Well, we don't do that when you get to pre-calc. You have to sometimes make your own function based on the situation, and then find g of that function. Like stick the 5 in, which means g of 5 would be 2 times 5 minus 7. All right, so let's write this function together for this one with the ducks. This function, g, well, I'm going to call it g of x then, equals, and would you agree, you pretty much always have an x in the actual function rule. There's going to be an x over there. Okay, now, what are you supposed to do to the number? You're supposed to add 4 and multiply by 3 in that order. How are you going to make it add 4 before, exactly, parentheses. So I got to make it add the 4 first and then times it by 3. I can put the 3 in front of it or at the end of it, but either way, I want my parentheses like that. Now, some people might say, well, could you multiply that out? Yeah, you can, but you could just leave it alone, too. If you multiplied it out, it'd be 3x plus 12, and you'd have to be like, what? But you said to add 4, and you're adding 12. It's about the order that you do it in. If you really are forced to do this plus 4 first and then times by 3, you're going to really be adding more than you thought. Simplest if you just leave it alone and put in parentheses to force the order to be right. Okay, so there. Find g of 5 now. G of x we already did. It's right here. Find g of 5. Now you stick the 5 in the function. Would you please get your answer and compare with the kid next to you to make sure that you aren't like completely lost here? Get an answer in the 20s? Okay. You should have stuck in 5 in here, and that's 20. No, it's not. It's 5 plus 4. 9 times 3, 27. Raise your hand if you had a 27. Okay, good. Moving on. This is a little more complicated function. And you're going to find f of 5 again, but you're trying to make a function where you will multiply by c and then add t. Please write what you think that function is. It's not this. That's an advanced question we're going to do in a minute. Try to write the function. How do we make pre-calc harder than regular? Because there's a lot of times where it's just variables instead of numbers. Whereas in the past we might have said, hey, move it over 3 and up 2. Now we're going to say move it over a and down q. You know what I mean? You just change it to variables, and it makes it more abstract. So here, I'm going to take my x. Notice you always have to have an x over there. Otherwise, it wasn't a function of x, then, was it? Unless you have an x. So I got an x, and I'm going to multiply by c, and I'm going to add t. Now, will the way I just wrote that do the problem in the right order? Just think about it carefully. Will it multiply first if I do it this way? Yeah, it will. And it'll add t seconds. So yeah, I've got it right. I don't want parentheses on this one. Okay? All right, cool. Now, this is going to freak some people out, but find f of 5. What does it mean to find f of 5? That means stick 5 in. Where do you put the 5? Where the x is. So it's really 5c plus t. Raise your hand if you had 5c plus t. Awesome. Then, what's this one? Without any further explanation, you should be able to find f of w and then subtract t and see what you get. Don't say it. Figure it out. And then compare it with your kid next to you and see if you got the same thing as them. I'm going to pause for a second while I give that one a try. Okay, f of w means you put w in. But there's so many variables running around, it can get easy to forget where to put it. It goes in where the x was. So it's wc plus t. But then I have to subtract t. Well, it's that minus t. And then I can say, can't those just be combined as like terms? Yeah, they can. So what's plus t and minus t make? They're gone. 0. So that the answer is wc. Raise your hand if you had w times c or c times w. Awesome. Any questions about that? Okay. Then, implied domain. Say that's my function, 1 over x. Domain is what you can safely feed a function. Do you get that people are different and I can't safely feed everybody just the same thing? Like if I had peanuts out here and I gave all of you a peanut, most of you would be fine. But there might be one person who'd be like, oh, I'm shutting down. Okay, and if you were really super, super allergic to peanuts, some people even have do we still have the guy with the dog here? We did for a while. We had a guy had a dog that was his service dog, and if it smelled peanuts, it like, did whatever it did. I think it just sits down and like lays down and won't move. And then he knows he's like in danger. So anyway, 12 minutes left. So bottom line, implied domain is where you can't feed all functions the same thing. You'd think you could feed them any real number, but this one you can feed it everything except what is poisonous for this guy? 0. So your domain then is all real numbers except x cannot be 0. Another way to say that is it works from negative infinity up to 0, but that not 0. Union with starts working again after 0, goes to infinity. That's the domain of this guy, because I think you all know that the denominator can't be 0. Did you know that you can't divide by 0? If I put a 0 here, this thing will die. 1 over 0 doesn't exist. Some people get confused by that. How about 0 over 1? Can that exist? Yeah, that's just 0. But this, 1 over 0, it's not just 0. It doesn't exist. In fact, there's a special word for it. Undefined is actually used for this and only this. Other things that don't work, you're not supposed to say undefined. This is the reason you'd say undefined. That is not defined. There is no way to divide by 0. Okay, and then radicals. Why does it say even radicals? Let me show you. The square root of a negative is a problem. Do you remember this deal? You can only do it with imaginary numbers. That means it doesn't have any real answers. So if your square root ever becomes negative, you got a problem. But let's talk about cube roots for a second. Do they have any problem with negatives? If you understand what I'm saying, isn't there just a nice simple answer for this question? The cube root of negative 8, what is it? Is it 2 or is it negative 2? Negative 2. It doesn't care that, I mean, it cares that there's a negative, but it doesn't like crash because it's negative. Because negative 2 times negative 2 times negative 2 makes negative 8. So if you have a cube root, you don't ever have to worry about the function that's inside of it. That can't crash. Because if it was negative, it doesn't care. You just get a negative answer. But square roots, on the other hand, square roots, like here's my function, y equals the square root of 2x. Y is synonymous with f of x, right? So can that crash? Yeah, it could, depending on what you stuck in it. Some people get confused and think 0 is a problem under square roots. They're not. What's the square root of 0? It's just 0. No big deal. So do you get, in this case, that was what's under here has to be greater than or equal to 0. And then you just solve that little equation I just wrote. How do I get rid of the times 2? Divide 2, divide 2. Is 0 divided by 2 a problem? Right away, you got to know, is that the old kind? It is. It's just 0. So it's saying that in this function, x would have to be bigger than or equal to 0, otherwise it will crash. In other words, if you stick in a negative number right here, you're going to have a problem. You won't have a real answer. All right, so here is a typical question that is a high-level one. What's the domain? You got two issues. Number one, you can't be 0. Why can't x be 0? Which part does it hurt, the top or the bottom? It hurts the bottom of the function. You can't have a 0 down there. So x cannot be 0. And the other thing is that x plus 1 needs to stay bigger than or equal to 0. And then you can solve that. X has to be bigger than or equal to negative 1. Two problems. Now remember, a domain is what would work. 0 would crash it. So everything but 0 works? No. You have to stay bigger than negative 1. So how do I put that all on a number line? I say it can't be 0 by saying empty spot at 0. And then I say x has to be greater than or equal to negative 1. Here's negative 1. Greater than or equal to negative 1 is shading this way. Does that mean that all of a sudden 0 is accepted into the club and is part of the domain because I just shaded over it? No, we know if we put in a 0, just because it happens to work on the top doesn't mean it's going to work on the bottom. If you put a 0 on the bottom, this thing will crash. So if I left it that way, I'd be wrong. I have to erase my 0 here and say here, everything works except 0. There's my answer on a number line. That's as complicated as those can get. Here's a little more simple one. What's the domain? Well, you say what's underneath here has to stay positive. So x, 3x minus 1 has to be, come on, greater than or equal to 0. And then you solve it. That's how you get those kind of domains. What if it's this totally different question? I'll make it blue. G of x is 1 over 3x minus 5. Do I want to set the bottom greater than or equal to 0? No. I want to say the bottom cannot be 0. So I'd go 3x minus 5 can't be 0. And solve that. So what's the answer to the red one? Greater than or equal to 1/3. If I put anything smaller than that, this will turn negative and it'll die. Okay, how about this one? Then on this one, I'm going to add 5 to both sides. 3x not equal to, you don't use that sign very often, but we do now. X not equal to 5/3. It can be anything except 5/3. Because if you put 5/3 right here, 3's cancel, it'll be 5 minus 5, it'll be 0, and you'll have a problem. So my domain on the top one x had to be greater than or equal to 1/3. Domain on the bottom one, x cannot be 5/3. Okay, that's everything you have to know. I know that was a lot, and it went really fast. Your test isn't until Monday. Okay, so for tonight, we're in this strange zone where it's not really homework, but I'm giving you problems that you do not have to have done by tomorrow, but they're good problems that you could practice. Okay, and eventually they can be due someday, but they can't be due for a long time. So anyway, here's your assignment. Let's pull up the thing called homework. Here is the assignment. It's 2.2, day 1, and it's not due tomorrow, but I would recommend trying one of those. So we're not going to do this next one. It wouldn't hurt you to do it, but you don't have to. And on this page, these are really good ones, and this one has my favorite saying involved, so we'll do that one. And this one freaks people out sometimes because they're like, which do I do, the top or the bottom? Do you care if the top is 0? Is that a problem? Can the top be 0? Yeah, top can be 0, and that's okay. It's only the bottom you have to worry about. So try those two. On this page, this is the square root kind. Do you remember how you set what's underneath the square root? What do you do with that again? 6x minus 2 needs to be set. What? Can nobody in the room utter these words? 6x minus 2 has to be set what compared to 0? Greater than or equal to 0. Okay. Remember, you can be 0 in a square root. How about that? What did I say about cube roots? Doesn't matter. So what's the domain then if it doesn't matter what you put in? All real. So there you go. So do this whole page. They're not hard. They'll go quick. All right. And the one piecewise function, this one. And then nothing else. If we did all of that, you can't probably get that all done in class today. And it's not assigned as homework. But you'll have to know how to do all that stuff on the test on Friday. Or on Monday, sorry. Test on Monday. Okay? All right. The rest of the time is yours.